Hi everyone, this is Math 6 Lesson 2-2, represent rational numbers on the number line. In this lesson, we'll be able to represent rational numbers using a number line. Let's start with explore it. The locations of 4 animals relative to sea level are shown. Can you find the 4 animals here? Yeah, we got a seagull, we got dolphin, we got a shark, we got a cute little sea turtle. And we have locations shown for each animal. Seagull is 3/4 yard. Dolphin is -1/4 yard. Sea turtle, -1 yard. Shark, -0.5 yard. So they already tell you the locations are relative to sea level, right? So that means their sea level is represented by what? Your sea level should be represented by a 0. So if the sea level is represented by 0, what does it mean if dolphin is at -1/4 yard? Yeah, it might represent that the dolphin is is 1/4 yard, 1/4 yard below the sea level, right? And sea turtle would be a yard below sea level. Shark would be half below sea level. Seagull would be 3/4 yard above sea level. So negative numbers represent distances below sea level. Positive numbers would represent distances above sea level. So part A, what can you say about the animals and their positions relative to sea level? We just talked about it, right? Let's talk about positive numbers and negative numbers. We can say that the positive rational numbers show the locations of animals above sea level. The negative rational numbers show the locations of animals below sea level. Why did we specify the rational numbers? Because they're not just integers. Integers are counting numbers that are positive and negative, and including 0. Negative 0.5 and -1 1/4 and 3/4 are not integers. They are rational numbers. Part B, how can you use a number line to represent the locations of the animals? We have a vertical number line here, and 0 represents the sea level. How can we represent their locations? We know that the seagull is 3/4 above the sea level. You're going to divide this 0 to 1 tick into 4. And then you can write the fraction. That's 1/4. 2/4 is 1/2, right? And then that's 3/4. So this is where the seagull is. Seagull, right? And then what about -1/4? You do the same thing. Divide it by half. Divided by half again, you get -1/4 here, -1/2, -3/4 here. Okay? And so we have the dolphin, that's 1/4 below the sea level. So this is where the dolphin is. And shark, -0.5. So -0.5 is the same as -1/2. So this is where the shark is. Sea turtle would be at -1 yard. Okay. So looking at that, you can say you can write -0.5 as -1/2, and then you plot the points for each animal's location. Okay? All right, so if you have rational numbers, you might have to compare them with the integers to see where they exactly lie on the number line. Let's look at focus on math practices. How is representing the locations of negative functions and decimals like representing the locations of positive fractions and decimals? How is it different? So how is locating the positive numbers and negative numbers different? Or how are they similar? Well, how are they alike? You have to divide them into fractions, right? You have to divide your number line into fractions and then locate them in between the integers. How are they different? Positive numbers are going to be labeled above 0. Negative numbers are labeled below 0, right? So you divide units into equal parts to represent the locations of either negative or positive fractions and decimals. Negative and positive fractions and decimals are located on opposite sides of 0. There we go. Make sure you have all these in your notes. Let's look at the next page. The lesson essential question. How can you plot, compare, and order rational numbers using a number line? Let's look at example 1. Understanding rational numbers. What are rational numbers? Rational numbers are any number that can be written as the quotient of two integers, which means they can be written as a fraction. A rational number can be written in the form a over b or negative a over b, where a and b are integers, and b shouldn't be 0. Because if it's 0, you can't divide any number by 0, it's undefined. So it's not a real number. A rational number can be a whole number, fraction, or decimal. So whole number also is a part of rational number category. Okay, whole number, integers, they're all part of rational numbers. But rational numbers also includes decimals and fractions. How can you find and position negative 4 over 3 and negative 1.5 on the number line? So for example, before we look at negative 4 over 3 and negative 1.5, let's look at the example here. Negative 8 over 9 and 3 over 5 are rational numbers. Okay, and 1 is a rational number because it can be written as 1 over 1. Just like 1, any whole number could be written as a fraction with a denominator of 1. So 2 is also a rational number because 2 divided by 1 is 2, right? So 2 over 1 is 2. It could be written as a rational fraction. So yeah, all whole numbers are rational numbers. So let's come back to negative 4 over 3 and negative 1.5. How would you find a position on their number line? You know they're negatives, so you know on the horizontal number line, they would be on the left side of 0. One way is to use a horizontal number line to plot negative 4 over 3. And you can write negative 4 over 3 as a mixed number to see which two integers is it between. So negative 4 over 3 is negative 1 and 1/3 as a mixed number. That means from 0, you go 1, negative 1, and then you go 1/3 more from negative 1, right? So you have to divide the units on the number line into thirds and find 1 and then 1/3 to the left of 0. Another way you can plot it in a vertical number line. So from 0, you're going to go down instead of left. The numbers, all negative numbers are below 0. So you can write negative 1.5 as a mixed number, negative 1.5, right? And then you can divide your units into half and go 1.5 below the 0 on the number line. Okay, that's how you graph negative rational numbers on the number line. So now it's your turn. How can you find and position negative 5 over 4 and negative 1.75 on the number lines? Write negative 5 over 4 and negative 1.75 as mixed numbers, then plot the points on the number lines. So you're going to plot both points on both number lines. So write write -5/4 and -1.75 on the horizontal one and on the vertical one. 2 dots on the horizontal, 2 dots on the vertical. See if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? So what is -5/4 in a mixed number? Yeah, -1 and 1/4. So you're going to divide your unit into 1/4, right? You can divide it in half, divide in fourths, divide in half, divide in fourths. -1/4 is 1 and 1/4 on the left side of the number line, on the horizontal number line, right? So that's -5/4. And then on the vertical one, you also divide your units into fourths, and you go below 1 and 1/4 on the number line, and that is -5/4. Okay. What about -1.75? What is that in a mixed number? Well, you have 0. You already know what 1 is. It's 1. What about 0.75? 0.75 in fraction is 75/100. If you have two place values, you can put 2 zeros with the powers of 10 in your denominator to make it a fraction. Simplify this so that you get 3/4. So your mixed number is -1 and 3/4. So on your horizontal number line, you will go 1 and 1, 2, 3/4 on the left side of 0. So that's -1.75. Make sure you write the original values. And then on the vertical one, from 0 you go down 1 unit and 1, 2, 3 fourth on the number line below 0. So that's -1.75. Okay, check your answers. Now let's look at convince me. Why is it helpful to rename -5/4 and -1.75 as mixed numbers when plotting these points on number lines? Why is it helpful to rename? So like, why is it helpful to make them into a mixed number? Because you can count the whole number and then count the fraction separately, right? So the whole number part tells which integer the number is close to, and the fraction part tells the number of which parts in which to divide each unit. Okay, let's look at the next page. Example 2. Compare and order rational numbers. Haru was asked to compare and order 3 rational numbers. Show how he can use less than, greater than, or equal to compare 2/3, 1.75, and -0.75. Then order these numbers from least to greatest. So you're going to compare them using inequalities. Okay, do you know how to use them? This one is called less than. This one is called greater than. And this one is called equals to. Okay, so let's compare these numbers. 2/3, what is that in decimal? You divide 2 by 3 and you get 6 and 6 and 6, right? And so on, dot, 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 dot. So 2/3 is 0.666 repeated, and that's between 0 and 1. And this is in fourth, 1/4, 1/2, 3/4. But if you divide the unit into thirds, that's where 2/3 is, okay? And 1.75. 1.75 is between 1 and 2. You know that 0.75 is 3/4 from the previous example, right? Because 75 over 100 is 3/4. That's equal to 0.75. So you're going to go 1 and 3/4 to the right from 0. Negative 0.75 is negative 3/4. So it's right here. And so which one is the least? The one on the very left is the least. And then 2/3 is after that. 1.75 would be after that. So ordering these numbers from least to greatest, you get negative 0.75 and 2/3 and 1.75. Okay? Now it's your turn. Try number 2. If 1/4 is ordered within the list of numbers in the example above, between which two numbers would it be placed? Between which two integers would it be placed? So you can see that we've ordered them between two integers, right? 1.75 between 1 and 2, 2/3 between 0 and 1, negative 0.75 between 0 and negative 1. So 1/4. Where does 1/4 go? Between which two numbers? Well, integer-wise, it's going to go between 0 and 1. What about the numbers from example 2 here? Between which two numbers would it go? Would it go here? Would it go here? Would it be the least? Would it be the greatest? Where does 1/4 go? It would go between negative 0.75 and 2/3, right? Because 1/4 is right here, and 2/3 is a little bit bigger. But negative 0.75, 1/4, then 2/3. So 1/4 comes right here. Okay, let's look at example 3. Interpret rational numbers in real-world contexts. Sam and Rashida are scuba diving. Their locations are shown relative to sea level. Use less than, greater than, or equal to compare the two depths and explain the relationship. Sam swims at negative 25 feet. Rashida swims at negative 40 feet. So who is deeper? Who is closer to the sea level? Just by looking at the picture, you know that Rashida is below Sam. If 0 is right here, it's the sea level. Sam is at negative 25 feet below 25 feet below sea level, and Rashida is right here. It's negative 40 feet. So you know negative 40 is less than negative 25 on the number line, right? If that's 0, negative 25 here, negative 40 would be here. So it's less than negative 25. Rashida is at a greater depth than Sam. Sometimes negative numbers could be confusing. So please use the number line, either the vertical or the horizontal one, to see and check if your guess is right. Let's look at try it. At 10 p.m. one winter night, the temperature was negative 3 degrees Celsius. At midnight, the temperature was negative 7 degrees Celsius. Use less than, greater than, or equal to compare the two temperatures and explain their relationship. See if you can do it by yourself. Explain in your own words. Come back when you're ready for answers. Okay, how would you explain? We can say that on a number line or on a thermometer, negative 7 is below negative 3. So which one is less? Negative 7 is less. You're going to use the symbol. So negative 7 is less than negative 3. Negative 7 degrees Celsius is less than negative 3 degrees Celsius. And you're on your number line. should look like this. You have a 0, then 1, 2, 3, negative 3 here, 4, 5, 6, 7, negative 7 here, right? Yeah. And so let's also write that in words. Okay. So you can write on the vertical number line, negative 7 is below negative 3, so negative 7 degrees Celsius is less than negative 3 degrees Celsius. And the symbol less than tells us that negative 7 degrees Celsius is colder than negative 3 degrees Celsius. Okay, that is our lesson 2, representing rational numbers on the number line. Let's sum up our lesson. A rational number can be expressed as a fraction in the form a over b or negative a over b, where a and b are integers and b is not 0. So all rational numbers can be written as fractions. So all numbers that you already know are mostly rational numbers. There are some numbers that are not rational numbers, and we'll talk about that later. But yeah, there are numbers that you cannot write it as a fraction. But almost all the numbers that you see right now would be rational numbers. Okay, the number furthest to the left is the least number on the number line. The number furthest to the right is the greatest number on the number line. So the numbers in order from least to greatest are here, negative 1.75, 3 over 5, 1.25. So when you're ordering the numbers, you can either picture them in your mind on the number line as you get used to it, but make sure when you're confused, you use the number line either horizontally or vertically to order and list them from least to greatest. Make sure you read the question carefully because sometimes they'll tell you to order them from greatest to least. Then you have to write the greatest one first. So you might need to look at the right one first and then go to the left one. Okay? All right, that was lesson 2. We'll continue with lesson 3, which is about absolute values of rational numbers in the next video. Thanks for watching. Bye, guys.